Okay then, for today, ngizogcina kule video le. This is the electric field of a uniform ring of charge. So a ring of charge, you have a cycle, and then you have to construct the dotted line so that will indicate your direction. As we know that the direction of the electric field is the direction along the line. Okay. Then, as you see, A1 from the center, A to DQ. Okay, that DQ yenze a small portion. Then that DQ, ngoba ngishilo ukuthi that DQ ulingana nani no charge, which means ngalawe u-charge ukuthi u-Q wami elingane no DQ. And then ngase nga-constructor the dotted lines. And then when I construct the dotted lines, then the direction of the electric field is the direction along the line. Then I have DE1. And then I also constructed the dotted lines here. And then I have a direction along the lines too. I have DE2. And then, as I know that I have theta here. So, okay, DE2 have the components. It have X and Y components. DE1 also have the components X and Y components. Okay, let's focus on D2. On D2 will have the X component and the Y component. On D1 we'll have the X and Y component. So the Y components will cancel each other because they are equal but opposite in direction. According to Newton's third law, those forces, they will cancel each other. Okay. Then I have this, I allow Q to be equal to dq. Then I have the equation. Whenever I calculate the X component, I know that I use the Greek ratio, so I'll use cosine theta. So, electric field along the x-axis is ilingana no kq over r squared cosine theta. And then, as I said, that I allow q to be equal to dq, right? Then I wrote k dq over r squared cosine theta. Okay, how to find my r squared? I know that my r squared will be, I will apply the theorem of Pythagoras. Okay, I have my x here, I have my y here. And then I apply the theorem of Pythagoras. I say that r squared is equal to x squared plus y squared. And then at the end, I got r is equal to a squared plus x squared. Then finally, ngase ngishintsha ngenza a squared plus x squared all to the power of 1 over 2. Then 1 over 2 siyazi represent the square root, okay? Then ngabuya ngathi k dq over a squared plus x squared. Okay, the only reason I'm all squared it's because I said that r is equal to square root of a squared plus x squared. And then when I put this squared, square root squared cancel square root, and then I left with a squared plus x squared cosine theta. Alright, as I know in terms of Greek ratios that I have SOHCAHTOA. So cos is adjacent over hypotenuse. So in this case, as we can tell, I have my theta here. So my adjacent is x and my hypotenuse is this r. Remember that I got this r is equal to this. Okay, and then again, I have my x, and then I substituted my x for cosine theta. I substituted my x as I know that r is equal to a squared plus x squared all to the power of 1 over 2. And then I substituted, instead of r, I put a squared plus x squared to the power of 1 over 2. Okay. I continue with the components of the electric field along the x-axis. Then I have kq over r squared. Remember that we said that r squared is equal to, our r will be a squared plus x squared. Okay. Remember that we find that instead of cosine, we allow cosine to be equal to x all over a squared plus x squared all to the power of 1 over 2. So I will have k dq all over a squared plus x squared into, I open a square bracket, into this is cosine theta, which means it's the component of x. The component of x is cosine theta. So we allow cosine theta to be equal to x all over a squared plus x squared to the power of 1 over 2. Okay, and then at the end, At the end, I end up having, okay, oh, these are the like terms. Remember that this one is to the power of 1, and this one is to the power of 1 over 2. As we know that when we add 1 and 1 over 2, we get 3 over 2. Okay, fine. Then I take this x is the numerator, so I multiply this x with this k, which is the Coulomb's constant. So I'll have kx all over a squared plus x squared all to the power of 3 over 2, because these are the like terms. This is to the power of 1 and this is to the power of 1 over 2. 1 over 2 plus 1 will give me 3 over 2. Okay, then ex is equal to, now senya integrator. Mang integrator into ebalulekile ngizoyikhipha yini na, ngizokhipha ama-constant. Okay, I have kx all over a squared plus x squared to the power of 3 over 2 dq. Then this is equal to kx all over a squared plus x squared to the power of 3 over 2 dq. Remember that I said that dq is equal to q. All right. E is equal to kx all over a squared plus x squared to the power of 3 over 2. I allow this dq to be equal to q. Okay, thank you. This is the ring of charge.